Hey class, it's Mrs. Sorrells. Today we're going to be doing video 8.3 and we're going to be covering parallelograms. We're going to go as quick as we can here, but make sure we hit all the basics, okay? Alright, make sure you write the title down for the video on your paper so that you know which paper it is when you put it in your folder. Alright, if you look at parallelograms, you've got a word in here, parallel, that explains the whole reasoning behind a parallelogram. Okay, so let's write what parallel lines mean. And parallel lines are lines that will never intersect or they'll never run into each other. Okay, so let's write lines that will never, and I'm going to underline never, intersect. Okay, this is what it would look like. They're lines that run across from each other, next to each other, but they never will intersect. Okay, and a real life example of that would be railroad tracks, something along those lines. Okay. Alright, let's look at a couple examples of what a parallelogram you might see would look like. Let's see. You're going to draw this with me. Do the best you can to make it look like mine. Okay, notice that this and this are exactly parallel, meaning if I extended these lines here, remember dotted line kind of means like it's invisible, so I'm not really drawing it onto the shape, I'm just showing you that those are parallel and would never ever intersect. Same thing here. If I extended this pair of lines, this set of lines would never intersect. Okay. The other thing about a parallelogram is that opposite sides are the same length. So I'm going to use this little dash mark to say that this one is equivalent to the one on the bottom. And I'm going to use two lines here to say that these are equivalent. Now what that tells me is that this and this are different because this one has one and this one has two, but that these two are the same and that these two are the same, they match. Okay. Now what you need to know is that a parallelogram has two bases pretty much and two heights, but you get to choose which one, which base you're going to use for the formula. And we'll be looking at the formula tomorrow. We're not getting there today. Alright, the bottom here, this one down here, this could be the base. The one parallel to it could also be the base because they're equivalent. Okay. Now the height, let me get my different color. The height is going to be the same deal. We're going to have that little dude again, and he's going to walk up to the top of the mountain, but this time we have two peaks that he can pick from. Two tops of the mountain, okay? So if little dude walks up here and he's right here, if he dropped the rock off, the height would be on the outside of the parallelogram. But if he used this vertex, if little dude's standing up here and he dropped the rock, it would be on the inside. Now notice that this height is equivalent to this height. It doesn't matter which one you pick. You choose. If you like it on the inside of the parallelogram, pick this one. If you like it on the outside, pick this one. Okay? That's really it. This is your height. You find it the same way you would with the triangle. This is the height. This could be the base or this could be the base. Now remember, they might make it look like this. They might turn it just a little bit. They might have it look like this. Okay? And they might have it look like this. And they might put it back to its original position. So remember that it's your option to turn the paper around and make it look right. Okay? And then I want to talk about three other polygons that could be considered a parallelogram. Those three things, one would be a rectangle. Okay, a rectangle has two sets of parallel lines. There's one set and there's two sets. Okay, and opposite sides are the same length, so that would qualify as a parallelogram. Another one would be a rhombus. Okay, this is a rhombus. It could be a parallelogram. Actually, in a rhombus, all four sides are equivalent, but it still has two sets of parallel lines. That's the basis of a parallelogram. It's two sets of parallel lines. And the last one would be a square. I don't think I made a perfect square. Sure didn't. Here we go. Let's fix that. Okay, all four sides are equal on this as well, but it does, again, it has, this is one set of parallel lines, and the other set is right here. Okay, so those are a couple that could be also known as parallelograms. Alright, and that is the basis. Let's write one more thing, and then I'll get you out of here. A parallelogram, so we talked about parallel lines, but an actual parallelogram is defined by saying there are two sets of parallel lines. And that's it. There are two sets of parallel lines for the shape, for the polygon. Okay? Alright. Just a little review. We'll make sure we talk about this one more time before we start tomorrow. If you have questions, please be honest and add them on there. I'm seeing lots of goofy comments, okay, but add some that are really valuable so that we can make sure we understand what you are not understanding so we can correct that. Alright, y'all have a good night. Make sure you bring your notes tomorrow.